Hi class, today we are going to talk about conic sections. There are four types of conic sections: a circle, an ellipse, parabolas, and hyperbolas. They're called conic sections because they're all slices or sections of cones. So if you have two cones that you put on top of each other, kind of like the picture on your worksheet, if you slice it in at various angles, you get those four different shapes. And today we're going to be focused on the circle. So we're going to skip over this parabola section here and drop down to circles. And you've learned circles in geometry, so we're going to remind you of the circle formula. But the standard form for a circle is x minus h squared plus y minus k squared equals r squared. And with circles, you're also going to need to know the distance formula. The distance between 2 points, which could be 2 points on a circle or between the center and a point on the circle. The distance formula is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 quantity squared. And also the point slope formula, which is the preferred formula we use in AP Calculus, the preferred over the slope-intercept form. We like using y minus y sub 1 equals m times x minus x sub 1. So we're going to apply, starting with this first formula here, we're going to apply this formula to this example problem that you see off to the side. So over here in our example, this is not currently in the form we are looking for here. So we need to get this equation into this form, we're going to have to make some perfect squares here. We're going to need to complete the square. So in order to complete the square, to get this equation in that form, we're going to group our x's together and group our y's together. So I'm going to zoom in on this. So to group our x's, we're going to have x squared plus 2x, leave a space, plus y squared plus 4y, leave a space, and equals, and I'm going to bring that 11, add that 11 over to the other side, so it becomes a positive 11. Now I can go ahead and complete the square. So to complete the square, you may remember to decide what goes in your square here. You take half of your b value, half of the number in front of your x, which would be 1 in this case, and to put it in the square, you have to square it. So 1 squared is 1. But if I add 1 to this side, I better add 1 to the other side. Thou shalt do what to one side what thou dost to the other. Math commandment. All right, over here we have to decide what we're going to add in this square. So you take half of 4 is 2. 2 squared is 4. So if we add 4 in this box, we need to add 4 over here. And so now I can go ahead and write it as a perfect square. I can write it as x plus 1 squared plus, and then this becomes y plus 2 squared equals, and then 11 plus 5 is going to be 16. And now we have it in the form that we were hoping to have it in the form, x minus h squared plus y minus k squared equals r squared. So my center of this circle is -1, -2, because you do opposite signs when it's in parentheses, because it's x minus h, so it's really minus a -1, and y minus k, so it's minus a -2. So this is my center, so I can go plot a point at the center here. So here's my origin. I'm going to go left 1 and down 2. And then the radius, well, it equals r squared, so r squared equals 16, which means that r is 4. So that means from the center, I'm going to go up 4, 1, 2, 3, 4, right 4, 1, 2, 3, 4, down 4, 1, 2, 3, 4, and left 4, 1, 2, 3, 4. And then we can, oops, I missed it, yikes, should go through. And there we have our circle, because we were able to put it in the form that we are looking for. All right, so now you have an example. So now let's switch to your worksheet that looks like this. Find the one that says circles on it. It says Conic's Day 1 up at the top. Go ahead and put your name on it. And we're going to start by graphing a few of these. It says, note if r squared is not a perfect square, then leave r in simplified radical form, but use the decimal equivalent for graphing. For example, the square root of 12 is 2 squared roots of 3, but to graph it, we're going to need to know that that's about 3.46. All right, so let's go ahead and graph this first one together. So the center, my h and my k, it's always whatever's with the x. Since it's in parentheses, you're going to do the opposite sign. So if it's a -3 here, their center is a +3, or your x-coordinate of the center is a +3, and your y-coordinate here will be a -1, opposite signs. And if this is our r squared, then what do we square to get 4? We had to square a 2, so your radius is 2. So we can go ahead and graph that, go over 3, down 1. My radius is 2, up 2, over 2, down 2, and left 2. And there we have our circle. So I think you can go ahead and try part B and C on your own. Those are very similar to the example we just had. Let's move down to number 2, and I'll do an example with you from that section here. I think I'd like to try, let's do this last one over here. So my center, it's already in standard form, but they tried to trick us a little bit because they switched it around. But for your center, it's always an x and y coordinate, so whatever's with the x goes in my x place, and whatever's with the y goes in the y place. So with the x was a +2, so in here goes a -2. And with the y was at y plus 8, so here goes a -8. Now the radius is a little bit tricky because it's not perfect square. It's not 4, 9, 25, 16. Instead, set r squared equals 72 in this case. So when I square root both sides, I'm going to get r equals the square root of 72. You technically, when you square root both sides, you put a plus or a minus, but we don't need to do that in this case because we know our radius is not a negative number. And so we're going to need to break down the 72. So when you divide 72 by 2, since we know that's an even number, you're going to get 2 times 36. 36 breaks down into 6 and 6, and since we have 2 of the same numbers, I can pull out that, so I'm going to have 6 square roots of 2. So my radius is 6 square roots of 2. Now again, if we were graphing this, I would want to punch in on the calculator and see that 6 square roots of 2 is approximately 8.485. But for just this sake, it's not asking us to graph this one. So this is sufficient here, just leaving my 6 square roots of 2. All right, moving on to number 3, we've got 2 circles. They would like us to write the equation of the following circles. They look about kind of the same type of problem. I'll go ahead and I'll do the first one. So we need to figure out where the center is. So the center is left 1, 2, 3, 4, and up 1, 2, 3. So my center is -4, +3, since we went left and up. That is my h and my k. My radius, or r, is how far over do we go? 1, 2, 3, 4, 5. So my radius is 5. And that's all you need to write an equation. So our equation is x minus h, which is minus a -4, which makes it +4, squared, plus y minus k is 3 squared, equals r squared, and r squared is 25. So again, that's just using the formula on your formula sheet and plugging in what we know. So you can go ahead and do the same thing for this one right now. If you'd like to pause the video and do that right now, that would probably be a good idea. All right, let's move on to number 4. Number 4 would like us to give the equation of the circle that is tangent to the y-axis, and the center is -3, 2. So if we draw what that might look like. So if I have a point at -3, 2, that's my center, and we know we're tangent to the y-axis. This is my x-axis, this is my y-axis. Tangent just means, I'll go up here and use this as my example, but for a tangent line, it touches at only one point on a circle. So, you know, anything over here would be a tangent line. So this is a tangent line. Over here I'd have a tangent line. If you cross through the circle, like say you were here and then you cross through it, then that's a secant line. So we're looking for a tangent line to the y-axis, which means it's just going to barely touch the y-axis, which means the circle is going to look something like that, where my tangent line is right here along the y-axis. So we really need to figure out the radius, but we can figure out the radius because we know if it just touches here and I went over left 3 to get back to the y-axis, it would be, I'm 3 units away from the y-axis, so my radius would be 3, which makes r squared equal to 9, and then we just plug it into our formula. X minus h, this is my h and my k, so it becomes x plus 3 squared plus y minus 2 squared equals r squared, which is 9. All right, in number 5, it's asking us to compare circles 1 and 2, and circles 1 and 2 over here. Let's do part B together. In part B, let's see here, what do we know? Let's write down some important information. I know the center of this circle is -7, -4. Again, be careful because they switch the x and y's on us. And my radius would be the square root of 6. Because you'd have to, that's r squared, this is r squared. And my center here is -7, -4, and r equals 6. So when they want us to compare, we can say these circles have the same center at -7, -4. Circle number 1 has a smaller radius than circle number 2. So we could say also therefore if circle 1 has a smaller radius, then circle 1 is a smaller circle than circle number 2. So just what we're looking for is some reference to both the center and to the size of the circles. All right, let's go ahead and flip it. So you can go ahead and do part A on number 5. You can pause the video if you'd like. Let's move on to the back side. Oops, where's my back side? There's the back side. So, putting equations in standard form by completing the square. All right, so we just did we completed the square over here on your example sheet that we did earlier. But here's another little example if you just need to see the completing the square process again. Here they added the 11 over, completed the square by half of 6 is 3, 3 squared is 9, half of -8 is 4, 4 squared is 16, and then don't forget to add it to the other side. So let's do another example together here. So in example 2, we got to group the x's together. X squared minus 2x plus y squared plus 6y equals, bring that 10 to the other side, add it, so you're going to get a positive 10. And I like to draw the square in each part. So now I'm going to complete the square. We take half of my b value, so half of -2 is 1, -1 squared is 1, so then I have to add 1 to the other side. Take half of this, half of 6 is 3, 3 squared is 9, add 9 to the other side. So when I go ahead and, really we're factoring this, but we're really making it a perfect square, so it's x minus 1 squared, because that factors into x minus 1 times x minus 1, plus, and then we're factoring this into y plus 3 and y plus 3. Remember, this number is always half of this number, so half of 6 was 3, equals 20. And now our center is opposite sign, +1, -3. My radius, so r squared equals 20. You can square root both sides, so you're going to get r equals the square root of 20, which 20 breaks down into 2 and 10, 2 and 5. So you can pull out a 2, and you get 2 square roots of 5. All right, so let's look at number 6. In number 6, there's 2 of them, A and B. I think 6B looks a little more exciting to me. The reason why it looks exciting is in these you'll notice they have coefficients of 1, whereas here there's coefficients of 4. So I'm going to show you what to do with that. So we can go ahead and couple of things. You could group the x's and y's together. Yeah, I'm going to go ahead and group. I'm torn. I could either try to get rid of the 4's right now by dividing everything by 4, or I should group them. Maybe I'll group them first, because that's usually my first instinct. So I'll go 4x squared. There are no other x's. Plus 4y squared plus 36y, and then that number all by itself, I'm going to bring it to the other side, becomes a -5. But now I don't want to have a 4 in front of my variables, so I'm going to go ahead and divide everything by 4. So if we divide everything by 4, then I'll have x squared plus y squared plus 9y equals -5/4. And now we can go ahead and complete the square to get our perfect square. So we don't have to worry about this one because there's no other x's with it, so that we can just keep that as an x squared by itself. But over here, I need to decide what's going to go in my square. And that's a little tricky when you have an odd number here, but you do the same thing we always do. You take half of that number and then you square it. So half of 9/2, whoa, know that. Half of 9/2 squared would be 81/4. And if you add 81/4 to this side, we need to add 81/4 to the other side. And then we can write it as a perfect square. We have x squared plus, this is going to factor nicely into y plus 9/2 squared. Again, that comes from half of the 9/2 here is taking half of your middle term, equals, and then that's going to give me we are going to have 81/4 minus 5/4 is 76/4. Does that divide evenly? It does. 76 divided by 4 is 19. So we've got x squared plus y plus 9/2 squared equals 19. And that is your equation in standard form. Oops. And now we can go ahead and find the center. The center, when there's nothing that we're adding or subtracting from the x, then our x coordinate of our center is just 0. And then opposite sign, -9/2. And my radius will be the square root of 19, because r squared equals 19, and the square of 19 doesn't break down at all. All right, let's move on to number 7. So in number 7, let's see, which one do I want to do with you? They look pretty even. We'll go with the first one. So again, it's completing the square. So we have x squared minus 2x, leave a gap, plus y squared plus 8y, leave a gap, and add that 8 to the other side. Now we're going to complete the square. I'm going to do this one a little quicker. You can pause it if I'm going too fast. Complete the square. Half of -2 is -1. Squared is 1, so I add 1 to the other side. Half of 8 is 4. 4 squared is 16. Add 16 to the other side. And now I can write those as perfect squares. X minus 1 squared plus y plus 4 squared equals, and that's going to add up to be 25. Oh, that's nice and pretty. So my center is going to be +1, -4, opposite signs. And my radius is going to be 5. So we go ahead and graph that. Ooh, this is why I'm going to run out of room maybe. Let's see. Over 1, down 1, 2, 3, 4. Yep, I'm going to run a little bit out of room. My radius is 5, so I'm going to go up 5. 1, 2, 3, 4, 5, over 1, 2, 3, 4, 5, left 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5. Almost made it. And then we do our best to connect those as what looks sort of like a circle there. So now you can go ahead and try 7B on your own. And moving into the very last section here, it gives us pieces of the puzzle, and then we have to try to figure out the rest. So in it looks like number 8 and 10, they give us a center. They give us a center, and they give us an extra point. So those look alike. And then it looks like numbers 9 and 11 are similar also. So I'll do number 8 with you, and then you can do number 10 on your own. All right, so it says we've got the center, so we know that's my H and my K, and then it gives us a point to 5. So what are we missing? So we have our center. To have an equation, we need the only other thing that our circle formula gives us. If we have a center, we also need a radius. So we really need to find the radius here. Sometimes it helps to give yourself a little visual of what's happening. If we're at over 5, 1, 2, 3, 4, 5, down 3, that's the center. And then it goes through the point 2, 5, over 2, up 1, 2, 3, 4, 5. So it goes through the point here. If this is the center and this is a point, when we make a big circle here, we need to know this distance right here, because this distance is my radius, and that's what we're missing. We really need to figure out what the radius is. So to find out the distance between this point and this point, look what we have. We have a distance formula. So nice. Math is so beautiful. All right, so the distance formula is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So we're just going to take our points. I'm going to write the points right next to it so we can see it clearly. So this was at 5, negative 3, and this point up here was at 2, 5. It doesn't matter which one you call x1 and x2. I'll call this, let's see, since I graphed this one first, I'll call this one x1 and y1, and this x2 and y2. So then my distance equation, when I plug in x2, so the x2 would be 2 minus 5 squared, this is x2 minus x1, plus y2 is 5 minus a negative 3, which would make it a plus 3 squared. Clean that up. You're going to get negative 3 squared, so 3 squared is really just 9, plus 8, 5 plus 3 is 8, 8 squared is 64. And then that adds up to be the square root of 73, which is not a beautiful number, and that's okay. So that's my distance here, but my distance is really my radius of my circle. And so now we know r is the square root of 73, and we know our center was h and k, so we can write our formula. We can say x minus h, which is 5 squared, plus y minus a negative, which is y plus 3 squared, equals, and it equals r squared. So if r is the square root of 73 and we want r squared, you can square both sides. R squared would be the square root of 73 squared is just 73. And there's our equation of our circle. So now you can take that exact same process there and apply that to number 10. And we're going to end with numbers 9 and 11. 9 and 11 both give us the endpoints of a diameter. So we need to figure out, I'm going to sketch this one out. Let's see which one. This one, number 11, I think is a little bit messier, so I'll walk you through that one. So we need, I'm going to do a little graph. Sometimes I just like to get a visual of what's happening here. So we're going to go left 3 and up 2, over 1 and down 1, 2, 3, 4, 5. So those are the endpoints of the diameter, which means my center is, if I drew a line here, that's a little close for my diameter. I need to figure out where the center of that is. Oh, and there's a formula that we need that we didn't write down anywhere yet. But if you want to find the middle or the midpoint of two other points, there is a midpoint formula that you once upon a time learned about. The midpoint formula is x sub 1 plus x sub 2 divided by 2, comma, y sub 1 plus y sub 2 divided by 2. So basically you take your x values, which in this case are negative 3 and 2, or oh, that's not your x value, negative 3 is your x value, and 1, negative 5. So we add our two x values and we take half of them. So if we add my x values, I would have negative 3 plus 1, and then take half of it. And then here we'd add our y's. So we have 2 plus a negative 5, and then take half of it. So my midpoint becomes negative 2 over 2, which is negative 1, and then negative 3/2. And if you think about that, does that look like it could be over 1, down 1.5 for my midpoint? Probably. I might be a little off just because my lines are not evenly spaced apart here, but it seems to me that it would at least be in quadrant 3 somewhere. So now I have my midpoint, which is my center, so that's my h and my k. And now I need to find my radius. So now we have to do what we did in problem 8, where we take our center and one of our endpoints. It doesn't matter which one. I don't have a preference, so I'll just pick this first one here. So now I need to find the distance between those 2 points. So now we use our distance formula. So we'll say the distance is the square root of, and now if I write that point right there by the middle of it, negative 1 and negative 3/2. So it's my x2. So I'll call this one my x2 and my center my x1. So if I do x2, it's negative 3 minus a negative 1 is plus 1 squared, plus 2 minus a negative 3/2, which is plus 3/2 squared. Again, just to recap that, I did x2 minus x1 squared plus y2 minus y1 squared. And then that gives us, let's see, negative 2 squared would be 4, plus, this gets a little messy, this 2, I'm going to think of it as 4/2 plus 3/2 is 7/2. If I turn that, get a common denominator of 2, then that's 4/2 plus 3/2 adds up to be 7/2. But then when you square that, we get 49/4. And then I need to get a common denominator here, so I divide or put it over 1 multiplied by 4. So I'll now end up with 16 plus 49 is 65/4. So my diameter is the square root of 65/4. Or not my, yeah, that's my diameter. Did I say that? No, that's my distance between the 2 points, not my diameter. That is my radius, but that can be cleaned up to be the square root of 65 over 2 is my radius. Square root of 65, I don't think that breaks down. Let's see, 65 is divisible by 5, but then that becomes, oh no, I just lost the lights. Here we go, okay. I'm sitting too still. Okay, so anyway, that's my radius, so now we can plug in, we know everything. We know our center, so we have got x plus 1 squared plus y plus 3/2 squared equals r squared, but when I square this and I square this whole thing, I'm going to get 65 and square the 2 and you get 4, 65/4. And there we have it. All right, so now it's your job to go finish anything on this page and the other page so that this worksheet is complete. Thank you for being a great class, and we will talk to you soon.